I'm back. Today is Christmas Eve, and I've decided, because I only have one job and it doesn't start till 5, to finally film the second part of this Learn With Me series on electrical. So I want to start with some comments that I received. All right, let's go. I and Marvin said I'll upload videos later on how to use a multimeter. I guess let's watch it again, everybody.
So I'm gonna have to describe.
Basically, the video is how to check voltage on a multimeter for voltage AC. Depending on where you attach the sensors, I suppose, I don't know what the correct word is, you could read 0 voltage because you're on the same line. It'll cancel each other out. But if you're on a neutral and a black wire, it will read 120. But the diagram was helpful. I think it's good foundation to know, and also some words that I should be aware of. I think I want to do a little bit more research, but this is my takeaway. How to check voltage on multimeter. So it's on voltage AC. Load, i.e. electrical appliances, typically wired in parallel. Without a load, you can burn out a wire, and a closed circuit would mean that there is 0 reading on the multimeter. When it's an open circuit, you should read 120 volts on the multimeter for this light bulb example. Let's move on back to the comment. Next comment is gonna be from Yuli Flores. Try visiting the website All About Circuits. It pretty much has everything you need. What? There's some ads on here. Let me see. Oh, I see. Okay, so this is the breakdown of what they'll cover in each video. Out of the electronic systems, this is the very first one. And it says here, let's get started here in chapter 1. So let's watch this and I'll let you know how it goes. 5 minutes into it. And I think for me, I'm having a little bit of a difficult time getting excited about what he's talking about, because this is very dry. So I went to the textbooks because they say see table 3.3, refer to that when they're talking about that. So I was like, you know what, maybe I'm just gonna read it anyway. I don't really like the video lectures too much, and there's something weird about the audio. So I went to the textbook section. This is how you get there: education, textbooks, and then they have volume 1 and volume 2, the DC and AC. So I did this one, and looked through that and looked at the review, and I realized this is kind of something I already know. So I just did this one, and it took me to chapter 1, basic concept of electricity. And this one is actually, this is the same. I only read up to here, but this is really interesting so far. So I skimmed through the next article or next section of the textbook, which was called What Are Electric Circuits, which I think it's just a very detailed explanation of what I've learned in the last video, maybe even like a couple steps back. But I think this was really useful. I wrote some notes. Lots of free electrons equal conductors, i.e. copper or silver, aluminum. There was like dirty water, concrete. Little to no free electrons mean insulators like rubber. The next one I just read through very, very briefly. I skimmed through what are electric circuits. Basically, it's just a short section on when there's a break-in circuit, there's no flow. Okay, so I'm gonna come back to this because I really enjoyed the textbooks. The next comment was from Anthony Olivares, and he said the engineering mindset is an amazing channel. Two-way switching, explain how to wire two-way light switch. So my takeaway from the engineering mindsets how two-way light switches work video is that in the EU, a 3-way switch, where like the one I had in my hallway, I think I showed in like a handywoman diaries video, where one of my sconces, the hallway sconce, can be turned on and off at a switch upstairs and the switch downstairs. So that is called a three-way switch in the US. So they call it a two-way light switch in the EU, and he explained with the diagram with color-coded wires that they use in the EU to explain how it works, which was really hard for me to follow. And you can wire them differently so that you can turn a two-way or a three-way in the US to a one-way, or so like a single pole to a, what is it called? Is it a three-way pole? I don't know, in the US. So that was a little bit beyond what I could keep following based on the knowledge that I have. So the video I'm watching now is still from the electrical mindset, the engineering mindset, and it's called Electrical Current Explained, AC, DC, fuses, circuit breakers, multimeter, DFCI, ampere. I was watching up to like 13 minutes and then my internet froze. So we'll have to come back to that and finish. But what I've got so far is when we refer to electrical current, it's conventional current, which we believe to be, or which we assume to be positive, the electrons moving positive to negative. But electron flow, what engineers and scientists actually understand it to be, and what has been proven to flow, is actually negative to positive. So this is what's really happening. The video went over the symbol for AC, which is like that squiggly line, and then the solid line and the 3 dashes underneath is for DC. So when you look at a multimeter, those are the symbols that differentiate which is what, which I actually didn't know, so interesting. So there was also a diagram on how the multimeter reads for amps based on what voltage is coming out of a battery, the resistance, the ohms being the light bulbs. And this one is from Nesto Works. He works as a TaskRabbit, I think in Chicago or somewhere in Illinois. But anyway, I've gotten a lot of good information. He has a lot of how-to videos on there, and also like earnings, what you could expect from working for TaskRabbit over there. So if you're interested, go subscribe. So it says, basics, street power lines are high voltage. The box on the pole is a step-down transformer, lowers voltage for your home's electrical box. Oh, the box on the pole, okay. Fuse panel distributes it to the different circuits, so like the different switches that we have. The box has a neutral side, hot side, and ground. If the house has metal boxes and conduit, they are grounded. If boxes are plastic, there's a bare copper wire in the box. That's the ground. The ground is literally a copper rod buried in the ground outside. Yeah, because depending on if you like open up the cover plate for a light switch or something, and all the wires sit in like a little box, right? The electrical box. It could be made out of metal or it could be made out of plastic. Black wires are hot. They can also be called live common load. White is neutral. Usually you will find other colors like yellow and red. Non-contact voltage tester, which is like that pen that I have, helps easily locate the hot wire. Yes, it beeps red when it's hot. Multimeter, one lead to the white and one to the black should read 110 to 120 volts. Make sure you set it to volts AC. Okay, outlet tester is also handy, especially for GFCIs. Outlet tester is like, it kind of looks like a plug. I had it before when I was doing maintenance for that big company. On outlets and switches, make a loop on the wire and put the loop going clockwise when you screw in so it doesn't come off. Lights are usually simple, black to black, white to white, ground to ground screw. So he's basically describing how you would hardwire a appliance. This is like the bare bones minimum in understanding that I have, which allows you to actually change out ceiling lights and change out certain things. And basically that is to connect the like wires together. Fan boxes sometimes have two live wires. Fan boxes meaning ceiling light fans where you have, I have one right here. The fan, I have a fan on the outside of it but there's also a light. It's not just a fan. Fan boxes sometimes have 2 live wires, so 2 hots, one for the fan motor, one for the light, so they can be controlled separate. And there's usually wires running through the box to other boxes, and they are called travelers. Okay, so a lot of really good practical information there. I'm gonna turn this light with this light switch into a dimmer switch. There it is. Okay, it's number 1. It looks like without the cover plate, and the circuit is on up there. That switch number 1. So using a voltage tester, we know that this is hot because it beeps, and this is neutral. Where is that? Because it doesn't beep. And then when it's turned on, they should both beep. So I'm gonna connect the black wire to the black screw and the red wire to the red screw. We got one here, and we got one there. 2 light bulbs, both dimmable, as it says here. One is brighter, 800 lumens, and it's 60 watt. This is 40. I'm gonna try this one. And we'll turn it on. Okay. You know what? I feel like it's making a weird noise. It is. I turned it on with this one. It was making a weird noise. I'm gonna try this light bulb. I'm gonna turn it on. It's at the highest. That's what it looks like. I'm gonna dim it down. Dim but not completely off. Turn it off. When I had the 800 lumens, the brighter one, it was making like a really staticky, like faint, but definitely there, kind of staticky noise from the appliance. But when I did the 450 lumen one with the 40 watt, it's okay. So it could be maybe like the max load for the appliance can't take 60 watt. I don't know. Let me know if you guys know. But installing a dimmer switch on a regular switch was very easy. It looks so much brighter on video. I can dim it down. It's like, is it the light bulb? Because it's like so not bright. This one is the one that I just tried on and showed you how to turn it on. Put everything back, just as it was, and turn back the power. And look how much brighter it is. This is how it looks without the windows open. Okay, this is like just minutes after the other light bulb. My face looks with this light, this orangey, not the best color light, but it's so much brighter. Yeah, that pretty much is gonna be it for this video. Hopefully it was useful in some way. Hopefully it was not over your head, but do feel free to check out the videos and information, the links that I've talked about today, because I definitely want to revisit them. And if I found this useful, I'm sure somebody out there would too. But anyway, this is gonna be it for today's video. Hope you learned something, and I will see you in my next, probably the Handywoman Diaries. But Merry Christmas, and don't forget to subscribe, and I will see you in the next video. Peace.